folks, welcome back to the shop. Frank here. I thought I would spend a little bit of time today talking to you about the mini motor grader. There have been so many questions about why did I do this, how would I have done that, shouldn't I have done this, that I thought I would spend a few minutes doing a walkthrough of the grader and explaining how I put it together in considerable detail. At least some of the details of it I would like to do a deep dive on. Hopefully be able to give you enough information to do two things. Explain the criteria I had for building this and the way I built it. There were functional and operational requirements that I had, and also to give you information you would need in order to build one similar to this for yourself. I know a lot of people have asked me, how much could I buy it for? Is it for sale? It's not for sale, and I couldn't sell it for anywhere near what I have in terms of time and effort, not to mention the cost. So certainly a pretty good investment. I think I originally estimated $6,000 or $7,000 just for the pieces, parts to build it, plus the effort to build it over the course of 3 or 4 months. So it's not something that I'm going to sell, at least not this time in my life. Maybe at some point I will get to the point where I have to sell off some of this stuff, but with any luck that's down the pike a ways. But I would like to give you enough information to explain why I did stuff, maybe. Not to say that the way I did it is the only way or even the right way. It's the way I chose given multiple opportunities or multiple paths to go down. So we'll look at the machine pretty closely here, talk about the different components and what was involved in building them. And this is kind of going to be a supplement to the 2 previous videos on the channel from 3 or 4 years ago that were the build videos. So if you look at Motor Grader Build Part 1, Part 2, you'll see a lot of pictures, a lot of diagrams, of the construction, the components that went into it. I'm not going to show you those again. Maybe I might stick a few pictures in if I need to, but I want to talk about how things were done and why they were done the way they were done. So, all right, let's turn around, look at the machine, and we'll walk through some of the details. So let's talk about the front end for a few minutes. The grader is built from the components from 2 different Cub Cadet garden tractors from the 1970s. All right, so this is a standard Cub Cadet front axle, and it's got the standard tie rod here, hydraulic cylinder for power steering. In order to find a place to attach the opposite end of the cylinder, which normally comes down the side of the tractor, I wound up going underneath the tractor and welding a bracket to the front end here, the front clip. So in order to make that work then, I needed a separate crank arm. The traction frame, which supports the blade circle and the mold board, is attached to the front frame with a ball hitch arrangement. It does have a clevis pin here. It's got spring-loaded balls on it to keep it from coming out, so it's latched down. And that, of course, allows the traction frame to move side to side, up and down, cock, tilt one way or the other to some extent. So that was a simple way to do it. I felt like gave you plenty of strength because all the forces from grading are against this point. So the forces carried by this ball hitch, which are all the forces on the mold board, are transferred to this frame through this piece of the main frame and back, of course, to the rear end. Now you'll see a plate on here, piece of plating, and there's several of these at points to reinforce the weld connection between this piece and this piece, and it's just mitered together. So I was just learning to weld at the point I built this. So my welds are not that great on here, and it's also, they're not hot enough because the welder I had was a 110 volt welder. So, you know, my welds are not the greatest here. But everything's held together sufficiently. If we come up the frame a little bit, you'll see another mitered section here where this is welded. I beveled the edges and welded it and ground it somewhat smooth. So this is a 6x4 rectangular 1/4 inch wall tubing. I think it's 1/4 inch or 3/16. And you know, I cut it with my miter saw. I ruined the blade, of course, a carbide blade, but I didn't have a cold cut saw, didn't have a band saw that would reach through it. I mean, the only other way I could have cut this is with a zip disc. So I didn't have a stationary band saw or anything. So I did what I could. I used my miter saw, replaced the blade afterwards. And you can get metal cutting blades. It's just that the speed is too high for a standard miter saw to efficiently cut steel. I mean, I created a lot of sparks, as you can imagine, but it worked. And there may be some pictures on one of the earlier videos, build part 1 or 2, that showed me using my 12-inch Hitachi sliding compound miter saw to cut this tubing. I only had 1, 2, 3, 4, like 4 or 5 cuts to make, so it wasn't too terrible. All right. The next thing is how to support the traction frame. So let me back up here. All right, so here you have a pretty good view of the traction frame down here, and it's just welded out of 2.5 by 1 1/4 rectangular tubing, and so it makes like a delta wing here and has a single member that comes down the center, which bolts to the bolt circle and takes much of the load directly up to the trailer ball hitch. So on the traction frame, there's a lot of stuff going on. We'll talk first about the height adjustments. So as you can see, there's 2 vertical cylinders, and there's 2 connection points. There's a connection point here and a connection point down here on the frame. Both of these connection points have to have 3 degrees of freedom. They need to rotate in 3 different axes, all 3 axes, all right, in order to accommodate the varying motion of the traction frame. If you don't accommodate all 3 motions here and here, your equipment will bind up. You won't be able to operate it properly. So how did I accomplish that up for each of these 2 positions? So at this point, a lot of big motor graders have this point moved further out or up or different places. I'm about 6 inches away from the frame, and it works fine. I had to find a way to hold the cylinder, so I made these rings, these collars, and they clamp to the outside of the cylinder, and I welded axles to them basically. So then this pivots in this bracket back and forth. So there's one here and one on the other side. So this was custom fabricated so that this clamped on fixture would pivot in this bracket. So that's 1 degree of freedom. Now, it also needs 2 more degrees of freedom. The second one is built into these trunnions. There are bearings here that I fabricated, thrust bearings between 2 plates that fit together. And the one plate's welded to the frame, the other one is captured by a large bolt, like I think it's probably a 1-inch bolt that goes through, and there are thrust bearings inside that hold the two halves of this bearing from touching each other. And of course they're greased inside, and that allows the movement in this direction around this axle. So you've got one there, you've got one here. You need one more, and that's in the horizontal plane. That's accomplished by the fact that the rod, hydraulic cylinder rod, pivots freely within the cylinder. Okay, so that gives you your 3 degrees of freedom, right? So one here, and one here. So this one's vertical this way, this one's vertical this way, and then the bottom one's horizontal. So you need to build attachment points which pivot in all 3 planes. Same thing down on the bottom. But the same requirement applies here. This rotates on a thrust bearing between this bracket and the traction frame arm, and has a bolt that goes through it. So this bracket pivots there. There's a pin that goes through the end of the cylinder, the rod end of the cylinder, and that lets it rotate this way. And then the cylinder itself, the cylinder rod, rotates in the horizontal plane within the cylinder. So again, this has 3 degrees, 3 planes of motion. So you need to do that on basically everything that attaches to the traction frame. Now let's look at the traction frame from this side, where you get a pretty good view of a lot of stuff going on, right? So we're talking about the 3 degrees of freedom motion. So this, call it this, the skewing rod, or side shift, I think is another term. Anyway, it attaches to an arm on the other side of the frame, main frame, and it comes down to this point. So this point has to have 3 degrees of freedom again. So this bracket's similar to the other one, except instead of this, since this has a, I guess it's a clevis eye on the end of it, it's got a pin through a single point, whereas the other side had a rod eye captured between 2 plates on the bracket. And of course the bracket pivots as well, thrust bearing underneath it, bolted through, so it pivots on the traction frame. It pivots up and down on this way, and again the rod pivots this way in the cylinder. So again, this point has 3 degrees of freedom. The other end of the side shift cylinder again has another 3 degrees of freedom connection point to this bracket, which sticks out 15 inches or so from the main frame, and has a bolt through it, thrust washers, and pivot pins. Again, you got 3 degrees. The bracket pivots in the horizontal plane, rotates in this plane, and in the third plane by the piston rod within the cylinder, which rotates. Okay, a couple other things going on here. This mold board, suspended beneath this blade circle, is off of a 5-foot Land Pride 3-point hitch blade. So I took the bracket that holds the blade and the vertical rod and kept that, and used that vertical rod to come through the bolt circle and a piece of tubing here, and then it's bolted here, just like they are on the 3-point hitch tractors. Very similar arrangement. Now I've sandwiched a ring gear. This is off a Cummins 8.3 liter Cummins diesel that was just a ring gear. I had, this is before I had a plasma table, I had a disc water jetted for me at a local fabricator so I could put it inside and weld the disc to the gear, which was really only about 3/4 of an inch wide. So that created a large diameter gear I needed, Now, these are small teeth, and you really, there's a little bit of a concern here because you really would want much bigger teeth for their strength. You do have multiple small teeth, so it gives you a little bit more strength, but it would be better to have bigger teeth. So if you did this again, or I did this again, I would probably cut this out on the plasma table and adapt it with bigger teeth. But I got what I got because that's all I could do at the time. All right, so this disc, this gear, rotates with the mold board. The gear has holes drilled in it, and the plate, which is bolted to the mold board, this plate here is bolted to the mold board with a couple bolts here, a couple bolts over there, and bolted back here. So this plate is above the gear. Here's the gear down here. They both have 7/8 inch holes drilled in them. And the purpose of that on your 3-point hitch blade, that's used by dropping a pin to hold the blade at an angle. And you manually get off the tractor, move that pin to another pair of holes, lock it at the angle you want, and go ahead and plow your snow or whatever you're going to do. So I needed a way to lock it. And the first implementation, I did this, I locked it manually, just dropped a pin through these holes. But I wound up automating that, or at least being able to do it from the operator's seat by installing a cylinder. There's a small hydraulic cylinder in here. At the bottom of the cylinder is a pin which can go into or come out of the holes. And there's a whole series of holes, so you can use that pin to lock it at a whole bunch. The circle goes all the way around over here. So there's a big variety of holes that you can choose. There's a little wire here which is attached to the pin, comes up inside here, and it goes up and down with the pin. So it tells me from the operator's seat if the pin is down or up. And of course you need to use the pin to lock the gear and the mold board relative to the traction frame so that you don't put all the forces of the mold board on the gear teeth. Now the gear teeth are driven by the hydraulic motor. So the hydraulic motor here is a low RPM motor, and I don't know what it is. I don't know what the speed is anymore, but it's a couple RPM at my flow rate of 2 GPM, 600 PSI, which is the auxiliary hydraulic output of one of the hydrostatic transmissions. So if I didn't have the hydraulic transmissions, the hydrostatic transmissions with the hydraulic output, I would have to mount a separate hydraulic motor, separate hydraulic pump to operate all this. So I'm dealing with, and this is one of the limitations, I'm dealing with 600 PSI at about 2 GPM. And for operating the cylinders, that's plenty, or 2,500 PSI to operate anything. 600 or 700 PSI is plenty. I mean, over an 1.5 inch cylinder, you got over 1,000 pounds of force. All right, so this hydraulic motor then goes through the bottom, is mounted on this plate, and there's a little spur gear which meshes with the ring gear and rotates the wheel circle and hence the mold board. So that's the third component to do it. Now, you could do a simpler implementation here. If you wanted to put a pin in by yourself, you could just raise the mold board up, rotate it by hand, put the pin in, and you could do away with the motor and the hydraulic pin operation. That would simplify this particular arrangement considerably. Okay. So all told, all of the mechanisms on the traction frame here allow you to shift the blade sideways, either way. that depends on the length of this cylinder here, my skew cylinder or your side shift cylinder, and where it's located so that you want it to be able to shift both ways. Here it's extended almost all the way out to the right. And then the two lift cylinders, you can tilt the blade and rotate it, so you have all the functions from the operator's seat. The height of the blade is a thought. You want to put some time into deciding how you want to do that. You may want to raise this frame higher so that the traction frame will come up higher. And you can make these cylinders longer. There's really no limit to what you can do with these cylinders. And that's in order to get the blade up high enough perhaps to drive this on a trailer. And I have not attempted to put this on my flatbed trailer. I keep telling myself I'm going to do that, try to figure out if it's possible. Will this blade clear moving it onto my trailer? Now, there's a possibility that if I had to, I can pull this center bolt out of the middle of the blade mold board and with a couple other bolts drop the blade and give myself another 15, 16 inches of clearance. So all that would have to clear the ramp to get onto a flatbed trailer would be the traction frame itself, and you can raise it up, probably a foot higher than it is here sitting on the ground. So that's something to be considered. Worst case scenario, everything's pinned together with cotter pins. So it's possible that could remove all of the connection points and take the whole traction frame off. It would come off the ball hitch at the front, all the three connections for the lift cylinders. Now, I would have an issue with the motor, hydraulic motor, and the pinning mechanism. But the pin cylinder will come out. It just has one pin holding it in the vertical bracket. The hydraulic motor, that would be a little more complicated. There'd be 4 bolts to take off to remove the plate that the motor's bolted to. So with 15 or 20 minutes of work, you could probably disassemble what you needed to of the traction frame, remove it from the tractor, leaving all the hydraulic lines, on the tractor with the cylinders attached to the main frame. So you want to think about that. You're going to need to move it. How high does it need to clear your trailer, the ramps on your trailer, if you're going to do that. All right, so we're faced now with the operator's position, and this is a standard hydrostatic Cub Cadet from the early 70s, dash tower, instrumentation, ignition key, speed control lever, steering wheel. I've mounted a plate in front of the dash to carry the spool valves. So there's 4 spool valves here mounted to this plate. So these 2 spool valves control the height of the right side and the left side. These raise and lower the traction frame, right and left side of the traction frame. The 2 over here control rotating the blade circle and side shift. And these are double acting valves. So, you can rotate one way or shift it to the right and shift it to the left, rotate it one way, rotate it the other way. And these, of course, are up and then down, up and down for the elevation cylinders. There is one more spool valve on here, and it's this. So this is the original mower deck lift handle, operating handle for the hydraulics on these old Cub Cadet tractors. The hydraulic lift allowed you to lift a snow blower, lift on the front, a rototiller on the back, a mower deck in the middle, or any implement that you might put on the front, rear, or under the belly of the garden tractor. So this operates the pin mechanism. Okay. Now, I am working on a design for a scar fire, and there'll be more about that in a future episode. Right now my plasma table's actually broken. The plasma torch has failed, so got to get that fixed. So maybe a week or two before I can get back on the scar fire project. But so stay tuned for that if you're interested. People have suggested a ripper on the back, and I agree that would be cool, but you don't have really the weight of the horsepower for a big ripper. But you do need something to disturb the compacted road bed so that you can move the soil around more. When it's wet, when it's damp, the moldboard can dig in plenty and move stuff around. If it's dry, baked, and you haven't had rain in a while, it's a little more difficult for the moldboard to dig into the dirt. It takes several passes. I mean, you can do it, but it's just more time consuming. All right, so standard dash, you got switches for the lights, choke, throttle, speed control on this side, and the steering wheel. The seat position is a little compressed. When I was building it, I was paying attention as best I could to where the seat would wind up being, and it's a little close. It could be 3 or 4 inches back, a little further. For my size, for a smaller guy, I'm 6 feet 2 1/4, so I'm not a little guy, but I mean it does work. It's just not as roomy as my forklift is. I learned that when I built the forklift, so it made a big difference. Okay, a lot of people over the years have said you need a foot control. I normally use a speed control lever up on the dash, but there is a foot control here. So this foot operated, this foot pedal operates the hydrostat, and forward and reverse. Now it's not spring loaded, and what I probably would need to do is set it up so that it returns to neutral without operator assistance. And as I move this pedal, you can see the speed lever up here moving as well. So they are connected. And in order to really get this to work as it should, I would need to disconnect and remove all of the mechanism that's attached to the speed control lever, because that puts additional friction on the mechanism. So you wind up not having as fine speed control as you would like, as you might have on a current hydrostatic tractor. I mean, like my Kubota, for example, is hydrostatic. And you have pretty fine control, and it's spring-loaded back to neutral. So that is, I use it sometimes, but it's a little less easy to control. All right, the rest of the dash here is, basically from a Cub Cadet. When you get behind here is where some things start changing from a Cub Cadet. I will mention one more thing. This is a neutral return pedal. So if you hit that pedal, it puts the transmissions in neutral. So it's kind of like a brake. Okay. Before you start it, you normally would hit that pedal. That brings the 2 transmissions into neutral. And we'll talk about syncing the transmissions in a minute, but since there's 2 of them, that's what that is, neutral return. All right, so the back of the tractor, what do we have here? We've got 2 complete Cub Cadet hydrostatic rear ends, one in front of the other. They're about 24 inches, 26 inches apart. The wheel diameters are 23.5 by spec, and there's about 4 inches between them. What I wound up doing was taking the Cub Cadet frame, cutting it about here, and adding a segment. So this would be the rear of the frame, cutting it and inserting about a 20-inch piece of steel, another piece of frame actually, from the second tractor. When I took the transmission axle off of the second tractor, this being the first one, this back half being the first one, I took the frame with it and welded it in. So it's got a section of frame welded in to make the tractor longer. And then there's a couple of layers of steel here, basically just to raise the frame up enough to mount an engine over the transmissions. Normally the engine's mounted in line with the transmissions in a Cub Cadet garden tractor. But in order to drive both transaxles, there's a drive shaft between them, and the belts from the clutch, which we just put in last week, come down and drive the drive shaft, which is connected to the back input on this transmission and the front input on this transmission. So those are hydrostatic transmissions, and the hydrostatic transmission linkage between the two transmissions is linked together, and the length of the connecting point between the two is adjustable so that you can synchronize the two transmissions. It's the position of that linkage, which only moves about 2 inches to go from full reverse to full forward. The little trunnions that control the swash plates inside the hydrostatic transmissions only moves about 2 inches. So the cable that connects the two transmissions has a couple of turnbuckles built into it so that you can adjust the length and the position. So the two things that are important in synchronizing the transmissions is both trunnions need to be a controlled distance apart, and they both need to be in their proper position front to back. So you need to be able to make all those adjustments. This has a solid sliding shaft, flexible shaft. Someone said it's not a flexible shaft, it's a flexible rod. It's a push-pull cable in a sheath that's like a 50-pound push-pull or 100-pound push-pull cable from Granger. No, not Granger, McMaster car. Anyway, so the mounting points at the two transmissions for where the push-pull cable goes through, and the distance within that cable, front and back, changes the motion of the control of the two hydrostat transmissions. You wind up having to jack the whole back of the tractor up, run the engine in slow forward, and make sure both sets of wheels are turning forward in approximately the same speed. And you adjust the distance on that cable in order to synchronize the two transmissions. You can never get them perfectly synchronized, but you can get them really close, and certainly close enough for it to function reasonably well. All the way around all 6 wheels, I have wheel weights. That's kind of just a cosmetic thing because they really don't add enough weight to make a whole lot of difference. They're 26 pounds each or something. So I've got 150 pounds. You know, in the scheme of things, that's not that much. I estimate the whole tractor is about 2,000 pounds. All right, so we'll talk about the engine for a couple of minutes. So it is a standard Cub Cadet, 12 horsepower K-Series, K301 engine that would have come in one of the Cub Cadets, or this one probably came in the Cub Cadet. This may be one that I rebuilt. I think this is one that I totally rebuilt because it's been repainted and everything. So came out of a different tractor. I overhauled it. Had a local machine shop machine the cylinder, new piston, new rings, new rod. They honed the crank. So it's back together. So it's been a good runner. And it's mounted on a pivoting plate, as you saw last week or the week before. So that's my arrangement. So part of the steel layered on here brings up the height enough to do that without hitting the transmissions underneath. There was a couple comments about, why didn't you use an electric clutch? One guy said you need a spring tensioner, idler pulley on it. Others have commented about I'm wearing the bearings out in the engine by having tension on the belt. So I will address all of those. I couldn't find a centrifugal clutch with 2 belts, and one of my requirements was dual belts, so that a belt breaking doesn't strand me. I want to be able to continue working or load the vehicle up, load the tractor up and bring it home, or just drive it home. So dual belts was a first order requirement. Could not find an electric clutch that would do that. All right, another thing, the wearing out the bearings by putting the belts on a pulley on the front of the engine. Now, the bearings in this engine are great big, like 3-inch diameter ball bearings. I mean, they're massive bearings. And in fact, these tractors in operation had a front clutch with a pulley that drives the mower deck or any other implement. And those belts pull on the crankshaft just like, and in the same position as this pulley does. So running a pulley with belts on it in this position is no different than this way these tractors were originally built to operate indefinitely and for 50 years or more, right, with a belt pulling on a mechanical clutch, and in the later models, electromagnetic clutch, driving the mower deck, rototiller, snow blower, generator, whatever was mounted on these tractors. So I'm not the least bit concerned about wearing out the bearings in the crankshaft bearings in the engine from some tension on the belt. So not a factor. Obviously, I took the spring-loaded idler pulley off of the tractor a couple of weeks ago, and you saw that stuff come off, and the new centrifugal clutch installed. Which I have to say, after the last episode, plowing, I didn't put as much video footage of dirt piling up on the moldboard as I perhaps should have. The problem was a lot of the drone footage I took doing that was lost. And I don't know how or why. I think I lost the data card. It just wasn't on where I thought it was. So anyway, that's that. All right, that covers most everything that you need to think about building something like this. There's a couple other thoughts. Is you're going to need to find a place to mount the fuel tank, which is not in the normal position here. It's mounted on the other opposite end of the engine. The cooling exhaust comes through the engine toward the operator instead of away from the operator out the grill like it normally would. So the engine's turned around here. It normally would, the muffler would be on the front. So that's necessary to get the correct directional rotation of the pulley relative to the drive shaft between the transmissions. So you could turn this around, turn the engine around, turn the transmissions around if you went into the transmissions and flipped the ring gears. And I did that on the articulating tractor. I flipped the ring gears around, and I made some other changes. Rather than flipping the ring gears, I flipped around on the 4x4 articulating tractor, which I built a few months ago. If you look back on the channel, you'll see that. For the bulldozer, I needed speed equal in both directions. So what I wound up doing is modifying the swash plates in the hydrostatic transmissions. Normally, the transmissions are set up so that you have 8 miles an hour in forward maximum and 5 miles an hour in reverse maximum. In the bulldozer, I wanted the same speed front and back, so I modified the swash plates, which controls the speed inside the hydrostatic transmission. And if you go back and look at the early episodes of the bulldozer build, you'll see me doing that to the swash plates in the hydrostats. That allows them to, the swash plate to pivot just as much in forward as in reverse, and so you could get more speed in reverse than you could in forward. Of course, that piece of equipment is geared down anyway, but that's another way of getting forward speed, adequate forward speed, by turning the engine around and turning the transmissions around. So that would be another option. If you decide to do something like this, you should think about that and decide, what you want to do. The engine would be better if it were turned around and blowing hot air out the grill instead of on the operator's back. How are my boys doing? Come here, Brew Brew. Come here, Brew Brew. Oh, there's my Brew Brew. Oh, yeah. Hey, sit. 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 It's okay. Sit. Sit. Yeah, sit. Okay. Good boy. Give me that paw. Yeah. Come here, Butchie. Yeah. Come here, Butchie. Yeah, you're a good boy. Come here, Butchie. Where's my Butchie? Okay. There's my Butchie. You're my good boys. You're wet now. Is it raining outside? I guess it was supposed to rain. Today's Wednesday. It was supposed to rain. All right, so here's underneath the operator's seat. You can see one hydrostat down here, the swash plate, control the trunnion here, which controls the swash plate, and the cooling fan. And several people have asked about cooling the hydrostatic transmissions. All the hydrostats normally have a cooling fan of some sort on the drive shaft or whatever blowing over the hydrostat. The hydrostat's finned in order to, keep it cool. Let me see if I can get you a little closer because it's dark down there. All right, so here you can see the hydrostatic transmission here. And this is the control trunnion that controls the swash plate, which is inside. So the top of the hydrostatic transmission is a hydraulic pump, and the bottom of the transmission is a hydraulic motor. So the drive shaft drives the pump, the internals of the transmission, controlled by the swash plate, control flow of hydraulic fluid to the motor section. And the motor section then drives the gearbox and the rear transaxle. So you have one there, and then another one in the back. You can't even see it hardly. So, okay, and then a consideration in all these kinds of builds is where you're going to put the battery. It's not going to fit in the same spot necessarily that it used to fit in, so you need to find a place to do that. All right. Let's talk a second about hydraulics. Buying the valves and the hydraulic fittings and the hoses can get pretty expensive. I think on this tractor, it was my first one, actually second. I built the Gator before this, but where I had a sizable number of hoses. I spent well over $1,000 at my local Napa having hoses made up. Some of them are pretty long. They go up to the power steering. So big investment in hydraulic hoses. Now they sell a crimping machine, which I think I've shown on my channel in the articulating tractor build. I made my own cables. The crimping machine is $500 or $600 on eBay, and you can buy a spool of hose from Vevor. Buy your fittings from like surpluscenter.com. There may be some other discount hydraulic centers where you can buy the fittings, but if you go to your hardware store, your Napa, one of these fittings is $10 or $12 at Napa, and it's $2, $2.50, at Surplus Center or other places online. So you definitely want to buy your fittings online. The valve is $150 or $200 depending on exactly what you get. And again, surplus center is a good source for the valves. Also, Northern Tool. Used to be called Northern Tool and Hydraulics, but I think it's just Northern Tool now. So that's another option. There are places that sell pre-made lines of a certain length, and you might be able to find some that fit your situation. That it's important to find when you're building this. I had 2 transmissions, 2 transaxles. One of them came from a hydrostatic tractor, so I had a hydraulic lift capability on the old Cub Cadets, which means that one of the hydrostatic transmissions had the auxiliary hydraulic output ports, which is 600 or 700 psi and 1 or 2 GPM. I mean, I've never actually measured it. I understand it is 600 or 700. The actual GPM, it comes out pretty good. So I'm going to say it's a couple GPM. It's plenty to operate cylinders. You're not going to operate them as fast as a log splitter, but as fast as you need to move the cylinders, to adjust the position of the mold board or turn the tractor steering. It's plenty of capacity to do that. So that's one of the advantages of using the hydrostatic transmissions. Someone the other day said, you could have used a Power King. It's all gear drive. Well, I would have lost the hydraulics on one of the transmissions. I would have had to install a separate hydraulic pump, which, could be done, but, might not. It would be more trouble than it's worth when you get it right off of one of the transmissions. Another option that somebody suggested is bolt a hydraulic pump to the engine, drive that pump, and attach a motor, hydraulic motor, to the transmission, which I actually, after dealing with problems with the twin belts and my spring tensioning method, I actually did go down the path of a pump and motor, hydraulic pump and motor drive. And it could be done, but you need a sizable reservoir and substantial cooling to do that, because there's a tremendous amount of heat created in that situation. By driving the fluid, a large amount of fluid, you're talking 10 GPM at least, fluid going between the pump and the hydraulic motor. The other problem with that is it's so redundant. You got a hydraulic pump on the engine, driving a hydraulic motor connected to the drive shaft. Drive shaft's connected to the hydrostat, which is a hydraulic pump and motor. So it's pump, motor, reduction gear, differential. So that just wastes so much energy. From a 12 horsepower engine, you're already losing 1 or 2 horsepower to the hydrostatic transmissions. You do that again, you're going to lose 4. You're going to be down to 6 or 8 horsepower available to the rear wheels. So you need a bigger engine, and you could do that. And it would be no problem to do. And you could find a different engine with a different orientation and install it. There's really no limitation on the engines here. Over the years, there have been a lot of comments about you should have put a Kubota diesel in it, or Predator engine or something, an Onan diesel. And while you certainly could do that, it kind of flies in the face of my kind of overriding objective here, is to build it as a Cub Cadet, with the style and the equipment that, maybe Cub Cadet could have built one like in the day. I mean, obviously, the applications for something like this are, small enough that they would never make any money doing it. It would cost a lot of money to do this. In the day, these Cub Cadets cost $2,000 or $3,000. In 1972, $2,000 or $3,000 was a lot of money. And there's an old story that goes, one of the neighbors in the neighborhood bought a new Cadillac and a new Cub Cadet in the same week. And he had his buddies come over that weekend to look at his Cub Cadet. So Cub Cadets were big deal back in the day. I mean, they were the best of the best at the time. Now, that's not to disparage Power King, Wheel Horse, John Deere, Simplicity, anybody else, but the Cub Cadets, you know, they're still around. They're built like little tanks. The transmissions, the differentials are automotive size differentials. So, I mean, they got a ring gear this big around and a spider assembly. I mean, they're real equipment. Because they're based on the original Farmall Cub tractor, original tractor that International Harvester launched in the 50s and, you know, became a super popular small farm tractor for plowing and cultivating and that sort of thing. So the transmissions and differentials and drivetrain, gear train on the gear tractors have become super popular for pullers. And today, it's hard to find a gear drive Cub Cadet anymore. They're relatively unusual on Marketplace or whatever because they've all been sucked up by the pullers. They want the gear drives, and they're super rugged. I have a Cub Cadet 108, a 1972 tractor that I bought used in 1979. What's that? 50 years ago, almost, for $1,500, which was an extraordinary amount of money as a newlywed. Just been married 2 or 3 years. We bought a house on 1.5 acres. I needed something to cut the grass. My wife's father had a Cub Cadet, a 128. They lived on a farm, gentleman's farm, really, with some cattle and horses and stuff. And he was cutting a couple acres of lawn around the house, so he had a 128. So on his recommendation, we went to a local dealer and we bought a 108 and with a 42-inch mower deck. And I still have that tractor, and I still use that tractor here almost 50 years later, 47 years later, cutting the grass every week or every 10 days on this property. And I got almost 2 acres I cut. So, or 1.5 acres probably I cut. Now it does have a rebuilt engine. I did rebuild the engine in it one time about 10 years ago. But in constant use for that long is pretty incredible when you think about it. So my objective, the reason I don't have a Kubota engine in here is because it's a Cub Cadet, right? That's the whole purpose. It's a Cub Cadet. And try to save as much of the Cub Cadet logo, style, components, you know, as I can, so that it reveals its heritage, which, you know, intended to be a Cub Cadet. As have all of my other builds. And if you haven't seen any of the other builds of the Gator, there's a short couple videos on that, though not particularly involved. It's just a wagon to drive around the property. We use it. It's parked out in the backyard now, full of gardening stuff. The bulldozer, the forklift, the articulating tractor. So those are other things that we built, again, all styled after a Cub Cadet, using Cub Cadet components and styling. The hood, I think, is there on every one of them to reveal its heritage and to be honest to the objective of, you know, building things which look like they could have been made by International Harvester back in the day. Obviously, they weren't, but it's not always obvious. I have had people, and there's 6 or 7 people down the lane from me. I know them, a couple of them a little bit better than others, but I've met them all and we've talked and stuff. And I had this out working on the lane, and one of them came by and stopped, and we chatted for a few minutes, and he thought it was, you know, factory built. So I've had that comment a couple times. To me, it looks nothing like a factory would build. To me, it's, you know, pretty crude in terms of its the sheet metal and stuff, it's not what I would consider, professional, but it does work pretty well. So, I've always been pleased with that. All right, well, that's it for this walkthrough. I need it to fit in my garage, so it has to be, less than 20 feet long. This is 13 feet long. I do need to try to get it up on my flatbed, my 20-foot flatbed. I have not taken any of this stuff to tractor shows. There are no tractor shows where this would be appropriate or interesting within 5 or 6 hours of where I live, maybe even, that's about the minimum. So that's an issue. I have so many other things going on, hobbies in my life, besides working on this stuff. I've got a boat, I've got a couple different clubs I'm in, so I'm a pretty busy guy. Retired now, almost 10 years, and I don't know now how I ever had time to work. I'm just so busy. But I've been blessed, and blessed with a wonderful family, the ability to do this kind of stuff. I know some of you do similar stuff. I would love to see that. If you can send links to it, it would be very interesting. Certainly many of you have worked in metal fabrication, probably most of you more than me. I'm a relative novice. A lot of you know I've been a woodworker most of my adult life. I built a lot of furniture. I have posted some pictures of furniture I've built. But I kind of run out of room for furniture in the house. So got a couple Cub Cadets, bought one, found another one, spiraled out of control. Like in a couple of years, I had 6 or 7 Cub Cadets, rebuilding them, restoring them. My collection of now is 13 or 14, counting the equipment, tractors, and all of the Cub Cadets that I have that are standalone, and that's 7, 8, 9 of them, all been completely restored and are operable and running. So it's been a lot of fun playing with the Cub Cadets. Converting them to this equipment is, the next step. And I hope that as entertainment, watching the equipment work is interesting, entertaining, and certainly building them for me is a blast. I have so much fun working on this stuff and building them. I'm constantly thinking of the next build, the next thing to build. I am kind of running out of storage space, but I do have some thoughts. Tell me what you think about a Cub Cadet tractor that's kind of in a skid steer orientation where arms for either a forklift or a bucket originate at the rear behind the operator's seat and come up beside him and lift up. So a forklift built like that, like a telehandler kind of thing, wouldn't need a big counterweight or as much of a counterweight in the back as my current forklift does. It also wouldn't have the height limitations going through my garage. I have a garage here that's only 7 feet, the doors are only 7 feet tall. I can't get my forklift, which is back here, by the way. So my forklift mast is almost 8 feet tall. It's like 7 feet, 10 inches. And it'll fit through the door here because my doors are 8 feet tall. But I can't get it in my garage, and that's a weakness. And it has a 600-pound counterweight on the back of it. So the forklift will pick 1,200 pounds to 7 feet, or 6.5 feet. So it's been really, of all the pieces I've built, it's been the most useful. I use it more than anything else. As you get older, you start looking for ways to avoid picking stuff up if you can, and recommend that approach if you can manage it. Okay, I'm going to wrap it up. I hope this was interesting, gave you some more insight into the things I thought about as I was building this, and some of my objectives. Maybe explain some of the decisions I made. I will mention again the Scarifier build is going to come up here in the next couple weeks. So look out for that video. Subscribe if you haven't already so you don't miss notification. Hit the notification bell so you don't miss notification of upcoming episodes. And we'll see you next time. Thank you for watching.